Hello and welcome to my final project presentation for the Music and Audio Programming module. I'm Corey Ford and today I will be demonstrating the amp simulator I created named ToneStack Blender. ToneStack Blender emulates an amplification circuit offering C++ code for the preamp, ToneStack and power amp developed for Bella. The role of the preamp is to create a flow of electrons that are modulated by the output signal coming from the guitar's pickups, leading to a boosted input signal. The ToneStack then applies filters to sculpt the guitar's tone, which is again boosted by the power amp, such that it is suitable to drive the speaker. The challenge of modelling the pre- and power amp tubes is that they react in a non-linear manner. A standard triode vacuum tube consists of a heater, cathode, grid, and plate. The heater warms up the cathode, which sends a flow of electrons to the grid. The grid then provides resistance, changing the number of electrons that are sent to the plate, generating the amplified signal. Note that when the grid to cathode voltage is low enough, no electrons will move and the current will stop. In this work, we use two different designs for mimicking the vacuum tube architecture in code. Please see the report for more detail. Unlike the vacuum tube-based components, the ToneStack can be modelled as a linear filter, where various frequency responses are associated with certain guitar amp models. By performing a symbolic analysis of the 59 Fender Bassman ToneStack, and then applying discretization by bilinear transform, Yeo and Smith were able to derive coefficients which model the ToneStack as an infinite impulse response filter. In this project, ToneStacks were implemented for a Fender, Marshall, Vox, Soldano, and Mesa Boogie styled amp, borrowing from the Guitarix project and Tim Gett's work. Please see the report for more detail. The speaker emulation for this work is achieved using convolution. The impulse response of a Marshall cabinet recorded with a 57 microphone is convolved with the audio buffer. The ability to blend between different tone stacks is achieved through the following process. Firstly, the output from the preamp is duplicated and passed to ToneStacks A and B in turn. Each ToneStack is created as its own object, inheriting from the ToneStack class, which is a pure virtual, meaning that it contains functions that child classes must override. In other words, the factory design pattern is used. Please see the report for more detail. The two ToneStacks are scaled depending on a slider, allowing the user to blend between the two ToneStacks. Next, to minimise the effects of aliasing, beyond that warranted by distortion effects, a 10 Hz one-pole high-pass filter and a 10,000 Hz one-pole low-pass filter were applied as a post-processing step, before being processed by the speaker emulator. Let's now hear some of the sounds that a ToneStack Blender can achieve. These sounds were recorded by plugging the output of the Bella board directly into the input of a Focusrite Scarlett 2i2 interface. To evaluate ToneStack Blender, a comparison was made to the Marshall-styled amp simulator packaged with Logic Pro. Generally, the overall frequency response between the two tools was similar. The Logic plugin had a stronger decay in the lower frequencies, around 100 Hz, whereas ToneStack Blender sustained these until the end of the chord. The Logic plugin also had a narrower frequency range. For ToneStack Blender, the post-processing filters could be adjusted to match this more closely. This presentation discussed the design and evaluation of a virtual guitar amp, where the user can blend between emulations of the ToneStack circuitry for various amp models, named ToneStack Blender. Thanks for listening.